Sir, your mic is off.
Good morning, everybody. We started talking about separate compilation. Today we are gonna finish up that topic. Also, we are gonna finish up the namespaces topic too. Last time we said that we have a number of encapsulation rules. At the beginning of the semester, I think there is something wrong with my connection. I don't know what is happening. Can you guys hear me okay? How about now? Is it okay now?
Sir, your connection is not good.
Let me switch to wireless connection.
Sometimes we cannot hear you.
Is my voice okay now? Can you understand me? I look at the closed caption, and if it is okay, if the closed caption understands me, I understand that you guys are hearing me fine. But it looks like the closed caption doesn't work. Let me switch to this wireless. Okay, let's try this. It still says there is something wrong. I don't know what is happening. I mean, this is university's network system, and I am connected both wireless and wired. Let me try to switch to my cell phone connection. And if I am out of my quota, you guys are gonna pay me.
is fine.
Okay. Okay, I am reconnected. The cell phone did not work for some reason, and it looks like my closed captions are working. And if that speech recognizer works, then you should be able to understand what I am saying. Yeah, I think it works fine. Okay. So sorry for the delay. I don't know what happened. Let me turn off everybody's microphone. Okay, good. Okay. So last time, as we said that at the beginning of the semester, we talked about encapsulation. We said that encapsulation is putting together all the data and then the function that work on that data in the same place, and they are kind of isolated from the outside world. And we say that these are encapsulated. Whatever happens inside the class, it is the class's business. Nobody should care about what is happening inside the class. And now we are introducing some new rules. These rules are kind of derived from the previous rules. We are saying that all member variables should be private. Yeah, we already said that we should restrict access to the data members. Either we should use setters or getters, or we should eliminate them altogether with no setters or getters.
Sir, can you share screen?
I did not share the screen because I just restarted it. Okay. My screen is shared now. Okay, so all member variables should be private, and the basic class operation should be public member functions, friend or ordinary functions, overloaded operators, etc. The class definition and the prototypes together, it forms the interface of the class. An interface is the part seen by the customer or the user of the class. Okay, not the developer, but the user of the class. That customer most of the time is yourself. But when you behave as a customer yourself, you don't care about the details of your class. So you behave like a customer. You don't care about the details. But if you are behaving like a developer, then of course you need to know everything about the class. So the class implementation should be unavailable to the users of the class. Okay, even if it is that you, okay, even if the user is you, that implementation should not be should not be available. It should be unavailable to the users of the class. This is what we said last time. So why are we talking about these again? We are talking about these because we like to enforce these rules using the C++ mechanisms of include files and the implementation files. That's what we said last time. Okay, we have an interface file. This interface file is a header file. Okay, inside this interface file, all we have is, as I showed you last time, this is an interface file for the digital time. Okay, in this interface file, I have my class definition, my digital time constructors, my getters, and some modifiers, and I have all of my comments, and I have my friend operators. And this private part is private. The customer of this class should not read this part. Okay, the customer of this class should not read this part. The customer is only interested in the public section of the class definitions. This is interface file, and it contains the class definition with all the functions that is necessary for this class to be used. Okay. Remember, if we go back, can I find it? Can I find the header file for the PF array? Let me see. Let me try to open that. I think it was chapter 10. Was it chapter 10? The pointers, or chapter 9? Let me go find it. Chapter 10 maybe. Yeah, simple string is here. Okay. Maybe this was here. Okay, good. So let's look at the interface of the PF array D, partial field array. Okay. It has constructors, it has modifiers, it has getters, and etc. What did I say? I said that the rule said that, okay, the rule said that all member variables should be private. And if you like to access a data member, you should use the getters and setters. Some people think this as all the data members should have a setter and getter, okay? But if you look at this, do I have a setter and getter for use or capacity or this double A? Do I have any setters and getters for this? I don't see any. Okay, I don't see any setter for this pointer A, right? I don't have any. So am I violating the object-oriented rules? Why should not I provide a setter for A? Because that would be wrong, right? The double pointer A is a private that should not be modified in any way directly by the customer, by the user, okay? If you like to modify what A points to, what you need to do is you are going to do add element maybe, okay? And if you remember our modification to add element, we made this class fully dynamic. It was changing it, okay? Sometimes the assignment operator changes the value of this A, Okay, so I never said that each data member, private data member, should have a setter and getter. Sometimes this used has a getter, but it doesn't have a setter, right? I cannot say this would be very, very wrong. Let me try to write something wrong. This is completely against the rules of object-oriented programming, and I am trying to stress this out because people are doing this mistake a lot. Int value, okay, and I say use as value. Okay, of course this is not const, and this is a very, very wrong way of object-oriented programming. Okay, don't do this. If you do this during the exam or during your homeworks, I mean, you will lose serious amount of credits. Okay, this is definitely bad. Why is it bad? I am modifying this use with a random value, okay, and I am not checking anything about if I have that many elements valid. Even if I have that many elements valid, okay, this is not a usable function. You don't have such a thing, okay, because the used is only dependent on add elements. Only add elements is allowed to change the value of use because it is adding new elements, okay? And you might say that, how about this one? You are modifying used here. I am modifying used here because I am trying to ignore everything that I have in my partially filled array. If somebody has their microphone on again, I am going to I don't wanna could you guys turn off your microphones? Everybody turn off your microphones, because if I turn it off, you cannot use your microphone. Maybe somebody is. Okay. No, it looks like it is not. It is not the microphone. Okay. So again, this is very important. This one and this one is very, very different. This is okay. Line 28 is okay. Line 26 is very, very wrong. Okay. The compiler of course, will not object to it. Compiler will not say anything. Okay, because it's a perfectly syntax-wise valid function. But if you think in terms of object-oriented programming rules, this is a very bad thing, because you are modifying, you are letting somebody modify your internal data in a very, very uncongruent and wrong way. Okay, the same thing is valid for capacity. The same thing is valid for A. Okay, don't do this. Don't do this. Okay, let's go back. Okay, these are the encapsulation rules again. We talked about it. And we talked about the interface file. Interface file shows the class definition, and I have shown you an interface file, a nice interface file. Both PFRA and both PFRA and digital time, and here is the interface file for the digital time. And in fact, I don't have a setter for hour and minute in this one. It's fine, because with the constructor I can do that. Okay, I didn't let the user change the time with random values. I only have getters. That's fine. Okay, so this is the interface file. anybody has this file, okay, will include this file in their project, and they could use my digital time in their programs. For example, this time demo H, it says that, okay, I am going to use this namespace std, and I will include this d time H. Okay, I have to clock digital time objects, and I start using them. How do I know that there is this operator defined? I know it because it is here. Okay, interface says that. Okay, how do I know that there is a function named advanced and what it does? I know that because it is here. Okay, so interface file is just interface file is good enough, or interface file is sufficient for me to be able to write this code. Okay, I don't need the CD implementation. I don't need to have an implementation file to be able to compile this file. Okay, my client code. That's why it is very nice to have the header file only. Start my development as a customer. The implementation file can come later, much later. So somebody else might be working on the implementation file. That's fine. So I can work on this client code, and somebody's working on this implementation file. We can work on these two files in parallel. When we are done, the whole project is compilable and runnable, linkable. Okay, so that's the idea. I have a question. Are you going to talk about explicit keyword? No, because you missed the chance for it. I asked you about the conversion constructor. Did you guys go back and learn about the converting constructors? I thought about it, because if you don't know about the converting constructors, it doesn't make any sense to talk about explicit keyword. And in your new homework, you're going to use explicit keyword. Gökbey has a question. If a function which consists of only one line, can we implement it in the header file, or should we always implement it in the CPP file? I think we talked about this. As a rule of thumb, you should never implement anything in your header files, because header files are about interface. It is not about implementation. But many times what we did is like this header file here. Okay, if the function is so simple and it is so obvious what it does, we usually put these kind of single line implementations in our header. Okay, because get capacity is going to return the capacity. It is not going to be changed later. It's not going to check any validity, etc. It is a so simple function. So usually that's what they do. The C++ programmers, they say that the function is so simple and everybody guesses what it does. So this is not like a very detailed implementation. So I am going to put this in the header file. That's kind of the custom. So if it's a single line, not complicated single line like this getter, or like this one, if the capacity is same as used, it is full, right? So that's the rule of the thumb. But as the object-oriented programming language people says, don't do this kind of stuff. But in C++, as we said, that we are not a 100% object-oriented programming language. We have to carry some stuff from our C knowledge. Usually we do this kind of stuff. Usually we kind of let the customer peek in our data. Because in my header file, I have to have this, right? In my header file, I have to have this. Because the customer sees the main class internals here. I mean, this data is a very detailed information about how I am implementing this class. When I look at this, everything is kind of obvious, but the customer is not supposed to look at this one. Also, I would say that customer is not supposed to look at this one. Okay, good. So one of the reasons why we are, okay, one of the reasons why we are separating our interface from the implementation is, if let's look at this time demo CPP. What does it include? It includes d time h, right? Okay, d time h. I included d time h. I write this one, okay, and I compiled my code like this, minus c, and I'd say time demo.cpp, right? This is how I compile it. This is how I compile this file. When I compile this file, you don't see anything about the implementation of the digital time, right? Because the digital time is going to be compiled separately, like this, the time CPP. So they will be compiled separately. So to be able to compile this one, I don't need the dtime. All I need is dtime.h. So that means that if I modify anything in this file, if I modify anything in the implementation file, I don't have to compile my time demo.cpp. So because I separated my implementation from the header, right? These are two different things. So any changes to the implementation should not affect my client code or the user's code, unless you modify something here. You modify something in this header file. Let's say you modified, let's say get hour. Okay. Let me implement this here. Okay. Return hour, right? If I have implemented this single line thing here, and later if I make a change to this implementation, let's say I am going to return the hour, but I am going to return it like this. Okay, let's say I made this change. So what I am changing, it looks like I am changing the interface, but I am changing the implementation. If I do this, I have to recompile my time demo.cpp, and that's not a good thing. Okay, that's not a good thing, because I did not change the interface, I changed the implementation, but that makes me compile my client's code altogether. That's a bad thing. That's why we should avoid this kind of code altogether. Try to do everything in the implementation files. So you might ask, why do we have this then? Again, there is no chance of changing this. Okay, I am not going to change it because it is so simple, it is so obvious. Okay, for some reason I erased that one. Okay, so class separation, let's continue talking about interface, and the implementation files are different. Okay, the class header files, we put them in a separate header file. Header files are both in C and C++, our interface files. Okay, and we put all the class definitions and everything inside that header file. We already have seen examples of it. Class implementation files implement the classes. All the details, implementation details, are in the .cpp files. Of course, in my .cpp files, like this one, at the beginning I have to include this dtime.h. Okay, if I don't include it, okay, if I don't include this one, This line 12, doesn't make any sense for the compiler. Compiler will say that, what is digital time? It looks like a class, but I don't know such a class. Okay, it looks like somebody's implementing a class function, but I don't see such a class. So if I include this, then the compiler will know. Okay, the compiler will know. Okay, good. And the book says that, okay, typically give the interface file and implementation file the same name. That's what we did here. Okay, d times cpp and d times h. And all classes member function defined in this class, everything, right? Okay, and inside the cpp files, they include the executable code or the implementation details. Okay, good. Well, the book says that the function definition and including main, no, actually, I mean, of course, inside the CPP file, but the main is included inside the customer's code. Okay, we don't include main in our implementation files. Okay, you don't see any main functions inside this implementation file. Okay, the main belongs to the customer code. This is our customer code. In our customer code, of course, I include the necessary includes and also include the dtime.h. Okay, good. Okay, let's move on. Our class files, we talked about it. One thing that you learn from your C course is the guard against the multiple includes. As a rule of thumb, before you start writing any header file, you do this. You say that, what is my header file name? D time h. So I would say this. If not define d time h, then define it, and there is an end if at the end. Why are we doing this? We are doing this against the possibility of multiple includes, because sometimes, for some reasons, this can happen. Okay, if I end up including d time h more than once, okay, then that means that I am defining my digital time class more than once, and the compiler is going to give me error message. Okay, so for example, this one, see, okay, this is a good example here. I included IO stream in line 4, right? Then I included d time h, and d time h included IO stream again. So that means what? I am including IO stream 2 times. If they did not have this guard against multiple includes inside IO stream.h, okay, that would give me a compiler error. So sometimes it is not in your hand not to include a header file more than once. It has to happen because you are including some header files, and those header files are including other header files. Okay, and you may end up including the same header file more than once. To prevent this, this is what we do. We do the guard technique. We say that, okay, there is a preprocessor technique. If not defined my header file h, then I define it and do this. Question. If I erase this line, what happens? What happens if I erase this line? I erased this define line. Okay. If I remove this line, what happens? Anybody has any ideas? I erased line 8. It was defining the time age. I am waiting for your answer. I know you can hear me because the auto captioning stuff works. Okay, if nobody's answering, then I will pick somebody from the list. Okay, Çiğdem Öneş. Çiğdem, tell me what happens. Did I drop again? Can you guys hear me?
Yes, we can.
Okay, Çiğdem. Çiğdem, tell me what happens if I erase that line. Why nobody's talking? Çiğdem, are you there?
Correct. Answered in the chat already.
What?
The question has been answered in the chat already.
No, I don't see it. I don't see anything in the chat. All I see is the last time Gökbey had a question about CPP files.
I think it's not up on your screen, sir. I can see it and friends are working.
So what's happening?
Maybe if you can refresh the page somehow.
There is no okay, let me type a chat stuff there. I write test and it is being sent. Okay, you got the test?
Yes.
Sir.
I am not seeing anything that you guys typed. All I see is the last time is Gökbey asked a question about the one-line stuff. Okay, what did you guys write? Just write it again. Is Çiğdem there? Çiğdem, did she write anything?
Certain daytime is not defined, so it may be included for multiple times in the future in different include statements.
Yes, that's exactly right. If I don't define it, there is no point in doing this define if not defined thing. Okay, so this is the reason why we are doing it. And if I don't do if not defined thing, then again, I mean, both of them has to be together. One of them missing doesn't make the other do its job right. So both of them has to be there. Okay, this is a preprocessor thing again. This is a preprocessor thing. Okay, good. Let me go back and continue with our discussion about the separate compilation. Okay, we talked about this, and I think I am done. Separate compilation is this way, and from now on, including your new homework. Okay, from now on, including your new homework, you're gonna do your homeworks using this way for all the classes. Okay, you will have a header file and the implementation file, and your driver code or your customer code should not know anything about the implementation. It should be in a separate file. Okay, you either compile them with your hand or you write a make file. Okay, and you're gonna submit your homeworks that way. So I like to see all the implementation, and I like to see all the implementation and the interface separated from each other. Okay, good. If there are no questions about separate compilation, because I think I could not read your stuff, I am going to start the new topic. Let me try to sign off and sign in again, because there is something funny with my Teams. I will restart my Teams. You guys don't run away. I am coming back, okay? Okay, I'm back. Share my screen. And my captions are on. And chat history. I don't see what you have written. No, I don't see anything. Okay. Can somebody write something to the chat window?
Gebze write something.
Just somebody type test.
We did, sir.
I restarted my Teams, and I am not seeing anything. That means that I am not seeing anything, so that's a good thing. Use your microphone to ask your questions. Okay, good. So that's a better solution. Did I mess it up when I tried it? No, I mean, that cannot be. Okay, so let's start this new topic. If you have any questions, just tell me what the question is. Okay. So let's talk about namespaces. At the beginning of the semester, we said that the namespaces. Let's not forget about our recorder, because our recorder is okay. It is fine. It's fine. Okay. At the beginning of the semester, we said that let's ignore this namespace thing using namespace std. Okay. That is the using the directive. Okay. So we are going to talk about the namespaces, we are gonna learn the details of it, what they are really, and most importantly, we will learn about how to make new namespaces. Okay, how to make new namespaces. So the definition of namespace is this: a collection of name definitions. Okay, it is either class definitions, variable declarations, global constants, functions, and etc. So if you say that I have a namespace, and inside this namespace I have tens of classes, hundreds of functions, and tens of global constants, etc. You may say so. In fact, our namespace std, standard namespace, is something like that. Somebody has created this namespace std, and they put lots of classes inside this std. Okay, and if we like to use the classes or functions or global constants out of this std, we need to use the directive using namespace std. Okay, so the definition of namespace is this: a collection of name definitions. Okay, programs use why there is a need for std. I mean, why there is a need for namespace. In C, we didn't have any namespaces. Okay, everything, all the functions, all the globals are there. They say that C and C++ programs are very, very large. Okay, sometimes it is tens of thousands of lines of code. Okay, it is possible that two different classes have the same name. Okay, somebody has a name for digital time, other group has a name for digital time. If you like to compile and link these two files together, you cannot. Why? Because you cannot have two classes the same name. So what they say is that, okay, we are going to have namespaces. Every group, every project should have their own namespace so that we can keep them separated. Okay, so that we can keep them separated. Okay, in this case, whatever we have inside std, okay, you are saying that I like to use everything that is defined in std. Makes all definition in std namespace available. Okay, sometimes I don't want to do this. Sometimes you might say that as a programmer, I like to have an integer named cout, and its value is 7. I like to do this. I mean, cout is the name is important for me. I like to do this. So how are you gonna do that? If you like to do this, yes, you could. In that case, you are not going to use this directive using namespace std. Okay? Or sometimes you might say that I will have my own string class string. Okay, this will be my own string class, and in that case I am not going to, of course, use the std string. Okay, so this is the main reason why we have namespaces. If I didn't have the namespace std, then any cout would be coming from this std. Any string would be coming from this std. I cannot write this kind of stuff. Of course, you might say that, isn't this confusing? Yeah, it is confusing, and you should never declare an integer like cout, and you should never write a string class like this, but at least we know that it is possible. And when we generalize this discussion, you will see that we are not talking about the std class all the time. We are going to talk about std namespace all the time. We are going to talk about other namespaces. Okay, let me show you one example. Okay, for example, this one. Let's say I have two namespaces, namespace 1 and namespace 2. These are not std. Okay, these are different namespaces. Okay, let's say that this function is available inside this namespace 1 and namespace 2. Okay, If I like to call the function my function inside namespace 1, this is what would you what would you do? And this is what would you do? This is what you would do when you like to call function my function inside namespace 2. Okay, so we have never seen examples of using namespace other than std, but in a few minutes you're gonna see how to write your own namespace, and this will make more sense. Okay, any questions before I take a break? Any questions before I take a break? Remember, I cannot read what you are writing. For some reason, there is funny things going on with my Teams and my internet connection today. Any questions? Gökbey, has anybody written any questions?
There is no question, sir.
Do you have a question?
I don't.
Okay, then let's take 10 minutes of break. Let's be here around 11:33. Okay, as I said before, we have used the namespace std, and it contains many definitions, including the standard library. But that doesn't mean that all the names used in std is reserved. It is not, because you don't have to use the namespace std. Okay, it is your choice. If you prefer, you don't use any items from std, or there are ways of using only parts of it. Okay, only parts of it, and we are gonna see how. Before we go on, in C, as you remember, there was no namespace. Okay, and we never said that we are using this namespace or we are creating a namespace. C++ says that, okay, that namespace is the global namespace. In fact, C has a namespace that's the global namespace. If you don't specify a namespace when you are writing a class or function, and if you don't say I am using this namespace, you are using the global namespace. Okay, you are using the global namespace. All code goes in some namespace. Whatever you do, okay, you cannot say that I don't have a namespace. You have to have a namespace when you write a new class. Okay, but if you don't specify a namespace for your class, okay, that namespace is the global namespace. Okay, if you don't specify anything, if you don't specify I am using this namespace and etc., you are using the global namespace. So how do you use the global namespace? You no need for using directive. You don't say using namespace global. Okay, it is automatic. Okay, and global namespace is always available, and it is implied automatic using directive. Okay, so you are not going to see any name global namespace anywhere. It is always available, and if you don't provide a namespace, if you don't say that my class is part of this namespace, then in that case global namespace will be used for your classes. So remember this one, this is important. So we have been up to now in our all of classes, we have been adding our classes and functions to the global namespace, but you didn't know, okay, because you didn't have to know. That was a detail for you, but now you need to know this because this is an important concept. Okay, in C++, whatever you do, what kind of class you write, it has to go to some namespace, one form or another. If you specify your namespace, then that's fine. If you don't, then you are using the global namespace. Okay, you are using the global namespace. Okay, so as we said before, I showed you the example a few minutes ago. You may have multiple namespace. Okay, and in fact we have used multiple namespaces, std and global namespace. We use it all the time. To be able to use the std, we said that using namespace std, and for the global namespace we didn't say anything. Okay, so the question is, what happens if I have the same class name in both namespaces, both in std and in global? For example, here I say I am using the namespace std, and I am trying a class named string. Okay, and this class is going to do such and such and such, I don't know. Okay, so this is an error. Why? Because here I am trying to put this class into global namespace, and I already said that I am going to use the namespace std, and string is available inside my std. Let me make this, this is a better example because I included IOStream inside. Well, no, I think this is fine, yeah, because IOStream includes the string. Yeah, that's no problem. So this is going to be an error message. Why? Because class string is already available in std, and I am trying to introduce this class named string in my global namespace. That's an error message. That's what it says on this slide. Okay. So if I like to use the same name in both places, okay, the same name in both places, then I should do this. Okay. So let me go to this one, and maybe I can say, just take this out, put it in here, okay, and put it in a curly bracket, and put everything, maybe a, okay, good. Okay. So see, this using namespace is only valid between line 17 and line 63. And I will put this string in my global namespace. Okay. So both of them will be fine now. Okay. And so what is the difference between what I wrote and what the book says? The book says that maybe you should write your namespace 1 here and namespace 2. Since I am using global namespace to put my string on, then I am not going to have any problems. Okay, I don't have to write this because I don't use my namespace global. Okay, you don't say using namespace global. You just directly use it to be able to use a namespace from global. Of course, whenever I need to use that string, I have to be very careful. Okay, so that was one example. Any questions so far? Any questions so far? So namespaces, it looks like it's kind of extension of encapsulation, right? Remember what the idea of encapsulation was? You put related data together and the operations that work on that data together, and you put them in a capsule and you will call it a class, right? Now with the namespaces, we are kind of doing the same thing, but we are not doing it in terms of data. We are doing it in terms of functions and classes that are related together. So it's kind of an encapsulation mechanism. In namespace std, we have all the classes and functions about standard library. They are all related. Okay, and we put them together under the name std. And if you are developing a project, and if you have many classes that are related, you create your own namespace and you put all of them in that namespace. So it's kind of a encapsulation method. That's why this chapter 11 prefer to discuss this topic of separate compilation and namespaces together, because they are both serving the purposes of encapsulation. Okay, with the separate compilation, it says that we are using the encapsulation, but we should keep our interface from the implementation. That's what they said. And with the namespaces, we are saying that, okay, encapsulation is more general than the classes. Okay, we could use the encapsulation principle using a collection of classes or functions too. That's why these two things are put together in chapter 11. They are not unrelated, they are related. Okay, so this using directive, using directive, this is called using directive, has a block scope, and we know that. Okay, so so far we talked about how to use a namespace. Let's talk about how to create and then use a namespace. Creating namespace is very easy. You just say that, okay, this is my namespace and this is the code inside the namespace. Instead of talking about these slides, let me go to the example given by the book. Okay, again, the same example I will talk about. Let me close this stuff from previous. Okay, let's start from d time h again. In d time h, okay, of course I have my guards, line 2 and 3. I included iStream, okay, IOStream. And instead of saying at the beginning using namespace std, I say that these are called using declarations, okay? I am not saying that I am going to use the whole std library. I am not saying using namespace std. Instead, I am saying that I am going to use only two classes, two definitions from this std namespace. One of them is iStream, the other one is OStream. Other than that, I don't need anything else inside this header file, okay? So I need to be careful here because I don't want to introduce all the names defined in std in this header file. Okay, so this is how you create a namespace. Okay, you say that, okay, I am creating a namespace, and inside this namespace, okay, the name of the namespace is d times savage. Remember, the savage is the last name of the our textbook's author. Okay, usually you try to make your namespaces as unique as possible, because you don't want your namespace to be generic. The namespace A is not a good name. Namespace alpha is not a good name, because they are too generic. I mean, other people can come up with the same name. So digital time d time savage is a very unique name. Since you have your last name in your namespace, it is not that easy that somebody else will have the same namespace, because if two namespaces are the same name, then you are in trouble if they are being used at the same time. It looks like my captions are coming back very bad. Can you guys hear me okay? Am I breaking up?
We can hear you.
Yes, we can hear.
Oh, okay, so that means that my captioning is not working very well either. So I am getting my captions very, very late. Night is working fine, I guess. Okay, so this is how I create a namespace, and as we did before, line 55 is end of this namespace definition. So you might say that where is the implementation? So aren't we gonna put the implementation inside this namespace? Yes, we are gonna do that. Let's go to the implementation. Implementation is here. See, it's very similar. Using declarations, you'll say that I am going to use iStream, OStream, cout, and cin from the std library only. Okay, this is the way you import names from a namespace without including everything. Okay, without including everything. And then you say that there is a d time h. D time h is already defining the namespace, and here you are saying that I will continue adding more stuff to my namespace d time savage. Okay, this is my implementation now. My constructor. Okay, my constructor, my getter, my mutator, and again mutator operator equal to, and the other friend operators, and these private functions, remember? I put them all in the same namespace. So that means that you don't have to, create your namespace in the same file, okay? You keep adding to it. Here in dTime I added the class definition. In dTime CPP, I added the implementations of those class functions, including the constructors and private functions, etc. Okay. Why
don't we use using keyword for dTime switch?
Because I am already inside this namespace dTime savage. Okay, when I am creating it, here you are saying that how does the compiler know that digital time? Okay, I know that the digital time is inside dTime savage. Okay, you are saying that maybe we should using namespace dTime savage at the beginning of this file. I don't have to, because I am saying that I am adding more stuff to dTime savage. I am inside between line 12 and line 148. I am inside the namespace dTime savage. I don't have to do it. But when I come to this driver code or the customer code, now I have to do that. I am saying that, okay, I am saying that I am going to both use namespace std and use namespace dTime savage at the same time. Okay. Now I have to use it because I am not adding any new stuff to dTime savage, or I am not adding any stuff to namespace std. Okay. All I am doing is I am going to use names from these namespaces. Okay, what are digital time comes from dTime savage. Okay, cout comes from this std. Okay, and what else? These stream insertion. Okay, where does this come from? Where does this stream insertion operator come from? The one that I just highlighted.
STD, I guess.
STD, yes, exactly. How about this one? Where does this come from?
Class from operation overload.
But what namespace is this from?
dTime savage.
dTime savage, right? So this one is from std, and this one is from dTime savage. Two different classes, two different namespaces. Okay, and this is an example where I am using two namespaces at the same time. A few minutes ago, I think Atakan asked the question, how come we are not using this? I mean, how come I am not saying the same thing here? Okay. Why don't I? Because, I mean, what would happen if I do this? Nothing. I'm saying that I'm going to use the namespace dTime savage, but it doesn't make any difference, because here I am already inside the class. I am already inside the namespace. It doesn't make much sense to do both of them. Okay, so we don't do that. We continue creating our dTime savage here. I am already inside that namespace.
Is global namespace a bad thing, or does it matter?
No, actually, if the global namespace is a bad thing, then this would have been a bad thing. Where does main go? This main inside the application CPP. Where does main go? What namespace does the main belong to? Where does main go? What is the namespace of main? It's the global namespace, right? So one way or other, you're gonna have to put some stuff in your global namespace. And main is one of them, okay? Global namespace is not a bad thing, but if you are developing your own classes, usually we prefer you create a new namespace and put everything in that new namespace so that you don't have conflicts between the names from the other namespaces such as std. How many classes and how many functions and how many globals are there in standard namespace? Does anybody know? Does anybody know how many classes are defined inside std? I don't know it either, but it is not less than 1,000. Okay? There are more than 1,000 classes and the functions and the globals and etc. And the enumerations are defined inside std. So by coincidence, you may choose the same name with one of them, or sometimes you do it that way. I mean, sometimes you say that, okay, I like this name cout a lot, and I am going to have my own cout. Okay, I am going to have my own cout. So what is the way of doing that? Of course, you are going to create your own namespace and you will define your own cout. Okay, you are going to define your own cout in a new namespace, and you would say that, okay, the customer will not realize that he or she is using my cout, and in fact they will be using my cout. For some cases it might be necessary. Okay, good. Any other questions?
Can I ask a question, sir?
Sure.
Can we say using namespace std except cout? Everything in std except cout?
No, you cannot. You have to include everything, you have to use everything, or you have to say it one by one like we did here. Okay. Usually
So
this.
is there can I ask you a question?
Sure.
Is there a way to shorter type D time series? Sometimes it's too long namespace name. Make it shorter.
You mean DTS?
Yeah, I guess.
Well, I mean, the shorter the namespace name, better chances that you're gonna conflict with somebody else. So I don't suggest you doing it. And it is not. Well, you are saying that STD is so short, and since everybody knows about the STD, it is okay. But if you have a namespace and its name is just A or AB, that beats the purpose, right? I mean, why we are using the namespaces? We are using them. One of the reasons is we are using them to prevent these kind of name clashes. Okay. Of course, the better reason is for encapsulation, but if you end up having the same namespace, then that's going to be an ugly problem. And remember, when you are writing professional code, you will be using lots of libraries from many different third-party companies, and each one will have their own namespace. Okay, it's not going to be just std. In that case, there will be a better chance of name conflicts, and that would make more sense to have your own namespace and very uniquely named namespace. Okay, just copy paste it. It doesn't. I mean, it is not any longer than typing using namespace std, right? Maybe a few more keystrokes. Okay, good. Let's go back. And so this is how I created the namespace, and then how I use it later. Okay, when I use it using namespace and my namespace, I have created the namespace. Okay, function declaration, and the greeting is here and greeting is there. So this is different from class declaration or class definition, okay? I continue adding more stuff to my namespace. Question for you here. Since I can do this, how about this? Okay, this is possible, right? I am adding a new class to d times which is an empty class. But I don't want to do that. I like to do this. How about this? What did I do? Somebody tell me. What did I do, and is this a valid addition? Okay, the first question. What did I do?
You added empty class to the std namespace.
Exactly. I have added an empty class B named B to standard namespace. Is this a good idea? But first of all, I mean, I could do that. Why? Because namespace std there, and I am adding this to namespace std. This is not a class definition, okay? You may think that I cannot add any new functions to the class string. Yes, that's true, but I may add more classes to any namespaces that I like. And this is what I am doing, adding a new class to std. Is this a good idea?
I don't think so.
It's not a good idea. Why? Because standard means standard, right? When you say standard, everybody should understand the same thing. If everybody, all the C++ programmers start adding new stuff to std, it doesn't, it is not std anymore. It is not standard anymore. Everybody has their own standard, and that would be very confusing. So this line from 11 to 14, syntax-wise, it is valid. I can compile it and I can add it, but I should not do it, okay? But I should not do it, okay? I should not do it. Of course, if I do this, okay, this is a compiler error. Why? Because you cannot have two string classes inside the same namespace. Okay, this is a compiler error. This is not a compiler error, but this is not a good idea. So don't do this. Okay, good. I didn't give this example just for you not to do something. I gave you this example so that you understand it better. Okay, that was an example about creating a namespace and using declarations. Okay, we most of the time use the using directive. Okay, using directive. Using directive is not a preprocessor thing. It's a C++ thing, okay? And using declarations are similar. This is an example from using declaration. This is an example from using declaration, okay? This is using directive. Using directive. This is using declaration. So in terms of efficiency, in terms of how the program compiles, there is no difference between them. But if you have lots of stuff that you need to include from the std, writing them one by one, like 50 lines of code here, is not a good idea. Maybe you should just use namespace std and forget about the rest. Okay, so they end up the same, but of course they are two different things. Okay, so declaration and directive is different. up to now, most of the time, okay, we used using directive. That means using namespace std or using namespace digital time savage. So what is using directive? It makes all names in the namespace available, okay, and only potentially introduce them, and we're going to talk about this. This one says that using declaration makes one name in namespace available and introduce the name so other users of the name are not allowed. Okay, so with the using declaration, just you are saying that I am going to use this one, and it becomes available for you. Some people think that when you say using namespace std will be introduced to your program, it will introduce all of those thousands of declarations to your program. No, it does not. Okay, it only potentially introduces them. Okay, here in this code, when you say using namespace std, only cout, cin, and these stream insertion operators will be included from this std. Okay, it potentially includes them. It says it potentially introduces them. But if you do that, okay, iStream, OStream, and cout and cin definitely are defined in your program. They are definitely defined. Okay, so that's kind of the difference between them. Depending on your needs, you may choose one way or the other one. I mean, in terms of generated code, it will be exactly the same code. Compiler will not get tired. Okay, you might think that, oh, that's thousands of definitions. No, it is not. Okay, first of all, if you let's go back here. Okay, let's go to this one. If I don't include this IO stream here, okay, and all I do is I'm going to erase everything. Okay, all I do is just this. Okay, this will not introduce anything to your program because I am not using anything from std. Okay, just compile this program to assembly and see what is happening with the assembly. You will see that your assembly code will be very, very short. Okay, and in fact, you may compile this using -E option. Okay, using E option. In that case, you are gonna see that your produced C code, C++ code will be very, very short. So don't think this as a don't think this as a very expensive compiler line. It is not. Okay, when you do this, okay, and when you start using the elements from, for example, when you do this, you have to still, okay, does this compile? Question, does this compile? Does this compile?
Yes.
The answer is not yes.
We don't have iStream.
Yeah, you did not include the IO stream. So some people are confused. They say that, why do I need to both include the IO stream and using namespace std? Okay, when you say using namespace std, the compiler says that, okay, there is a namespace std, it's going to come. Whenever I see it, whatever inside that std namespace will be available. But it didn't see anything. It will see it, okay, it will see it when you do the this inclusion. Okay, when you do this inclusion, come on, okay, doesn't matter if it comes before the IO stream or after the IO stream. Okay, without doing this, this will not be valid because cout is defined inside this header file, but inside that header file there is a namespace named std. Okay, so you have to say both. So line 3 is not an alternative for line 2. Line 2 is not an alternative for line 3. Okay, and if you don't include this one, that means that cout is part of, you are thinking that cout is part of a global namespace, but in fact it is not, right? It is not. I think somebody was asking a question. I see a hand raised. What happened to the hand?
Somebody, sir.
So you asked the question?
Yeah, I want to ask a question about our primitive types is from global namespace.
No, your primitive types are from the C++ language. Integers, doubles, characters, they are not part of a library. Okay?
All right.
They are defined by the C++ language.
All right.
Okay, the class vector, the class string, they are parts of this std namespace and standard library.
Okay.
Okay, so to use integer I, where is I? Okay. To use integer I, you don't need any namespaces, including the global namespace, because integer is a reserved keyword. It's part of the language. Whatever you do, you cannot have a function named integer. Okay? You cannot have a function named integer. With the namespaces, it is okay to have a integer named cout or printf, because if you don't include the std using statement, using directive, you may define an integer named printf or cout. But with integer, you cannot know. You cannot have a function named integer int. Okay, good. Any other questions? Okay, let's go back. So we looked at the differences between the using declarations and directive. Okay, sometimes people prefer doing this. They say that, okay, I'm not going to use any using statements. Instead, I will directly use their names. Let's give an example. Okay, let me put this back to the original. I need lots of stuff here. Okay, good. Okay, so get rid of this one, and you could say this, and you could say this. Okay, so with you are saying that I am going to use cout and cin, and all the couts and cins will be automatically included in your, like that. So it makes sense to use this notation, qualifying notation, if you don't use that many names from a standard namespace. Okay? If you don't use that many names from a standard namespace, in that case, you may use the qualifying names like this one. That means that I am going to use this function named fun1 from this namespace, and I'm calling it. You are calling it directly. So you are going to see this kind of a notation, many times, especially with the parameters, function parameters. Okay. Naming namespaces, I think I have this question. Usually they suggest you include your last name or your institution name in your namespaces to make it more unique. Okay, so it reduces the chance of other namespaces. It reduces the chance of other namespaces with the same name, collisions, conflicts. Okay, so it must have distinct names. If you prefer short names for your namespaces, there will be better chances of having conflicts with the other people's short names. Short names are good for typing, but other people can type the same short name by accident. Okay, so naming namespace, make it unique. Try to make it unique. Okay, so this example is from the book, and I already shown you this. In my header file, I have created a namespace. I put my class definition inside this namespace. And here I am saying that other than iStream and OStream, I am not going to use anything else from the std in this header file. Okay, this is my header file, and this is my CPP file, the implementation file. Here I am saying that these are the things that I am using from the STT. Okay, of course I will need this dtimeH, and I am going to continue adding more stuff to dtimeSavage namespace. Then after that, of course, my driver code or my client code is here. I say that, do I have anything? Okay. Okay, good. So here I am saying that I am not going to add anything to std. I am not going to add anything to dtimeSavage. All I am going to do is I am going to use names from dtimeSavage. Or if you prefer, you don't have to do that. You could do just this. Okay. This is fine. So I use the qualifying name for the digital time class.
How will operator overload work? Just like this.
Yeah, well, these are the operator overloads. These are part of the class or the friends of the class. Okay, when you say I am talking about this digital time, okay, it say that okay, these are my objects, and I know where they are defined, and I know all the operation. I mean, see, this assignment operator is part of this class, right? Assignment operator. This one is not a part of the class, but this class already said that there is a friend function inside this namespace, and use it that one, so it knows it automatically. So that's a very good question. You are saying that shouldn't I say that there is an operator overload inside this namespace and make it explicit like this? So it's like you are almost saying something like this. You are almost saying something like this, right? It looks funny, but you are saying something like that. No, you don't have to do that that way. But that's a good point. Remember, in our dtimeH, I talk about them. The compiler knows about them. Okay, good. One last concept, which is very important actually, unnamed namespaces. This is very important. Okay, so listen carefully. First, I need to make a definition, compilation unit. Compilation unit is this. It's a file, it's a C++ file, along with all files included in the file. Okay, so compilation unit, remember our -e option? Where is my, okay, where is, okay. Manual page for G++. Remember our -e option? What does -e do? Remember -e? It produces, CPP test? Okay, let me try to compile this -e first CPP. Okay. This one, okay. F unit dot cpp. So I compiled it. So minus e means that everything, I am expanding everything in that first.cpp. I am expanding everything in that first.cpp, and I am putting that everything in f unit cpp. So how many lines in, I don't know, how many lines in first cpp? There are 14 lines, but the expanded version.
Sir, your microphone is on.
Somebody turned off my microphone. Somebody turned off my microphone. Okay. So how many lines by F unit? It is 28,000 lines. You remember this one, right? Because inside the F unit, I don't have any includes anymore. All the includes are included and they are pasted in this file. Okay. Now I have 28,000 lines. So this F unit is the compilation unit for this first.cpp. First.cpp is this, very simple. Okay. And this one, it is very simple. It's just two functions. I think I use them for telling you something about this overloading stuff. It's a very simple thing, but it includes this IO stream, and IO stream includes many other things. So I end up a function, I end up a program that is as long as almost 30,000 lines of code, right? So my compilation unit is, in this case, 30,000 lines. That's the definition of compilation unit. A file along with all files included in file. Okay? So why did I introduce this idea of compilation unit? Because every compilation unit has a unnamed namespace. Okay, that's a funny name, unnamed namespace. If a namespace doesn't have a name, how am I gonna use it? How am I gonna define it? But you're gonna see it is a very good idea actually. Okay. Unnamed namespaces are written the same way, but they don't have any name, as the name implies. And all the names that are local to compilation unit can go to unnamed namespace. It's not like a global namespace. You are saying that I have a namespace, but you are not giving any name. So let me show you one example, and after that we will finish up this chapter. Let me, okay. I think the last part of the same example again. Okay. So this one, our driver code or the client code, IO stream and D time. Okay. I have my C out from STD, C in from STD, and digital time is used that way. Okay. Let's go to D time H. It is the same, exactly the same thing. Okay. It's exactly the same thing. But as you see, in my private section, let's compare it with the previous D time H. In my private section, I had three functions. These three functions, remember these functions, these are static. I never liked them. Okay, I said that these should not be part of the class because they don't belong to this class. They don't work on this hour and minute. These are like global functions, but I don't like global functions either. So these are related to this class, the time class, but they are not working on this data because all the data they need is from the input or from the keyboard. Okay, so we said that in order to show that, I mean, these should not be part of the interface. I made them private also. I made them static so that I know that they cannot work on this data. Still, I am not feeling very good about it. So the solution is here is this. Take them out. Okay, take them out of this class. And when we go to implementation is this. See this funny namespace creation statement? You say namespace. When you use a namespace like this, it becomes an unnamed namespace. Okay, unnamed namespace. And inside this unnamed namespace, I have these functions. See, these functions are written like globals. Okay, 3 functions, they are written like globals, but they are not globals actually. These functions belong to the compilation unit of this D times CPP. Compilation unit of D times CPP. Okay, I am not saying that these are the part of the D times CPP's unnamed namespace, okay, because unnamed namespace shared by the compilation unit. So what is the compilation unit? Compilation unit is all the definitions, okay, all the definitions along all the file content along with all the files included in the file. Okay, so unnamed namespace is defined. I put all of my functions that are local to this compilation unit, and then I continue creating my D times savage with the public operations. Okay, and I did that. It looks like I am out of time. I think tomorrow morning we will start from this point, and we will revisit this. We will revisit this unnamed namespace concept, and after that we will start a new chapter. Your midterm exam will be next week. Okay, your midterm exam will be next week. It is going to be most probably on Tuesday. Okay, on Tuesday, but we will make the decision tomorrow morning. Okay, so your exam will be next week. Okay, I'll see you tomorrow morning.